next few days. So the very first one, we are trying to introduce you to Python, but I'll tell you why this is sort of important. So this particular module, we will try to get you into teaching some of the syntax. Any program, any language, like English or Latin or something. Any language got things, grammars that you need to learn. Otherwise, you're going to say something that's going to be weird to the other person who kind of try to understand it. So you need to know the semantics and syntax, how the language works. So that's what we're going to learn very early on, and try to kind of give you very basic idea, like how these things kind of libraries and things like that, how it works. I'll try to kind of get you through the idea of, what is an IDE. So if you don't know what is an IDE, what it means by an IDE, we call it integrated development environment. So let me try to have a notepad so that way, whenever I say something that probably that, let's see, give me 1 second. Let me get the bigger font. That we can see. So what I mean by IDE, integrated development environment. So it's called IDE, integrated development environment. When you're learning a language, the interface that you're going to see that's going to help you to code, we call it an IDE. So there are tons of different languages have different IDEs provided. So we're going to learn about the IDE that we're going to use some of these IDEs like Anaconda, Spider, or also the browser-based Google Colab. And we'll learn some of the basic things, how to solve problems. And then we learn some of the basic stuff about it, and then learn things that gonna be important for the summer camp. So it's not really that I'm not gonna cover end-to-end everything, but I'm gonna give you enough basic things that you can learn, when you get interested about the language, you can learn on your own later on. Right? So that's what is the purpose of this particular module. All right, so you're gonna see that Python came up recently. it was there for quite some time, but getting increasingly popular. You're gonna, I don't know whether you know this, but when I was doing my college back in 2001, so you can see how old I am. When I was doing it, C language was the most popular. And then there's some C++, we majorly we done for coding on Java coding language. I'll explain what is a programming language, coding language, if you're new to this. But what I want to tell you is why Python is that it's closer to how we human speak. Right? So that's why it's popular. It's much less restrictive than a language like Java or C++, because it gives you kind of a nice way of doing this or coding. Especially that, probably this is like a news to you, that a lot of top schools actually change their very first coding language. Because if you go to college, especially what we call 100 level, the freshmen, when you go to college, the very first programming, if you choose computer science, most of the schools used to still, like even ODU, have Java or C++. I think we have C++. So this is actually changed, last few years, like MIT, Stanford, a lot of top schools actually changed entirely to Python. So they are teaching Python. And we are actually trying to get our university, our department also agree to do Python. So, that's, you can see that industry kind of changing to that. A lot of these data science kind of use Python, and it's increasingly used everywhere. When it comes to Java, it was, or C++, it was a little bit tough to kind of understand or learn, too complex. So it's more like people who want to do computer science learn those languages. But now Python is like everyday thing, like everybody can learn Python. So that makes it very easy. Even, kids in elementary. I mentioned about the Old Donation School in Virginia Beach. It's the gifted school for the Virginia Beach School District. It's right next to my house. I actually changed their curriculum. I spoke with their teacher, and I actually changed their computer science curriculum to Python recently, last year. So they are actually now teaching Python in grade 5, grade 6, and grade 7. So you can see now, you're on grade 9, so you don't have to really get intimidated by Python if you are learning it, because kids at the 5th grade actually learning Python now, so it's easy. So we try to kind of get you to coding. So why coding? This is kind of too cheesy because you are already with the technology. Just to kind of tell you that, stop me anytime, right? So like, if I'm going too fast, if you have a question, raise your hand. If I don't see it, just turn on your microphone and just talk. It's totally fine. Any questions so far? How this gonna work? Anything that you want to say? I'm looking at this side because I have my main screen here, and I have my secondary screen on this side I can see everybody. So that's why I always kind of look at this side. Any questions? All right, good. All right, so you can see that SpaceX sending rockets up there. If you saw the live streaming, you saw that people on the SpaceX facility, they have computer screens, put it up there. They are just looking at screens, looking at different interfaces, different data coming from the their launch vehicle. So you can see that Pathfinder, the Perseverance, that's on the way to Mars, the jets, power plants, all these things actually got some aspect of coding, because you need to have some sort of a computer coding. So this is sort of integrated. Even if you do medicine, you have to use computer interfaces. If you do something, let's say that you're going to be a specialist on cancer diagnostic, something, you probably need to use some of the interfaces to kind of handle things. So those things are done using coding languages, programming languages. So that's why coding is important, because it opens up a lot of avenues for you to learn things. So everything runs, our civilization run on computers. So that's what you need to remember. Hardware, software, when it comes to computing, what it means by part of the software, part of the hardware, the tangible stuff, intangible stuff, everything is kind of, we say that, that runs on computers, right? So that's very important. So, I'm not gonna go into you're right, it's too, I hope that you kind of know these stuff, but just to kind of tell you differently that how you learn, right? So I always want to kind of show you this idea on your head. Think of a human, right? We try to mimic us. We love to do that, everywhere that you can see that we try to kind of recreate us, because we are, in terms of, we are the most interesting kind of a thing out there, right? There are animals, other things, but still, we as intelligent human beings, we have very interesting stuff. Our brain kind of very interesting. Our vision, our senses, all these are very interesting. So we actually, the computer, you're going to see that we create computers just to replicate us. So everything is done just to kind of replicate us. So that's something I'm trying to get it to chat window. Give me 1 second. I don't know whether there are some chats. Give me 1 second. I'll move my chat window to somewhere. Give me 1 second. If you put something on chat, let me know also, maybe raising your hand so I can take a look. It seems like I cannot have both of them at the same time on my screen, but that's okay. All right. If you ask any questions on the chat, let me know, because it seems I can't see it on my screen for some reason. All right. So what it means by the computer and us human, you're going to see that computer processor, the brain of it. It's like a human brain. Right? The memory, it got a hard drive. that's a long-term memory. Like, that it's not, it's sort of a, we know that it's there because you have this long-term memory that, things that you did years ago, it's somewhere on your memory somewhere. We don't know where it is, somewhere it's there. And then we have very short-term memory, right? When you're studying for an exam, you just try to put everything into your head, and then you just go to the exam, write it down, and when next day comes, everything gone from the memory, right? That happens, right? So that's sort of like a short-term memory. You put it to your memory, but you never kind of train it, so it never went to your long-term. That's why it kind of gone. So we have that sort of a memory. We replicate it in computers. We call it RAM, random access memory, or caches. These are short memories that are up there. And then communication, your screen, your speakers, your keyboard, your input, output, all these are replicated in a way that how we sense things. Our eyes, we see stuff. Our brain, ears, our mouth, our skin, all these are sensors. So you can see that it's the same thing, right? And the reconfigurability, what it means by it, we can learn them, right? So we learn every day, we learn stuff. We learn how to walk. We learn how to speak. We learn how to do something. So all these are ability to reconfigure us, change us. So that's exactly what it means by a software, that you can change things. So you can see that it's the same thing, right? It's very easy to kind of see now that, oh yeah, it's computer means we are trying to replicate that, so it's, we try to kind of do the same thing. So that's what it means by computer. So when you understand that, you can see it's kind of a very easy, but it's a machine, right? It's not, in a sense, it's not really intelligent. It will do stuff when we say it to do. Right? We provide instructions, and it will do something, and it will spit out a result. So that's sort of the idea. So you need to kind of think of it in a sense that, again, like these are, if you feel like this is too fast, too much, I'm giving you slides. You can always go back and learn, but I'm not going to quiz you. So that means like, you can just listen. And you don't have to really kind of think deeply if you never heard these stuff before. But the idea is that these are created in a way that something called a cycle, so it's like a model. So it always, computer wants to know certain instruction, what should I do? So we send those instructions, writing a certain code, and then computer can decode that information, break it in, understand it, and do something. So that's a cycle. That's what happened. We say something to computer, like if I press the keyboard key, like say I'm going to press keyboard key character C, it says that C character, or display it somewhere. So computer memory gonna get that information, send it to the brain. It get that, decode it, and see what is it, and figure out and execute that information, show that thing in the screen. So this is what is happening underneath. So to do that happens, the computer needs to understand the language. So let me ask you this question. What is computer's language? What language does the computer speak? Can somebody answer that?
Binary.
Binary. So what is a binary?
Like zeros and ones.
Zeros and ones. So we call it machine language. Right? How many of you watch, what is it? What is that movie? Matrix series, right? So if you watch the Matrix series, remember that thing, like ones and zeros, like these, that goes, right? Ones and zeros, right? So that's exactly what it means by it, because computer understand ones and zeros, the binaries. So that means that we have our own language, but computer got ones and zeros, machine language. So we need a way to kind of communicate from our language to them. So very early on, people directly code in machine language, ones and zeros, and it's very hard. Think about it. So writing it or converting everything into ones and zeros was crazy back in the days, right? So you had to do punch cards, giving instructions exactly ones and zeros. But we realized that, we are lazy, right? I mean, we always try to find easy ways to kind of do it. We figure out, okay, that's too much, that's too boring. Let's try to find something closer to our language. That's where this programming language came into effect, that we can code it closer to us, and then some program kind of convert it back to the computer language, machine language. So that's how that things happen, ones and zeros, and we need to kind of do it to happen in ones and zeros. All right. So it's binary. Ones, like a switch on, like your lights, your switch to turn on your lights. So one is kind of on, zero is kind of off. Right? So it's like a numbers that ones and zeros, one bit represent that thing. So you're gonna you are in a time that this actually going to change pretty soon. Especially that you're going to realize in later that this idea of ones and zeros binary is kind of a very restrictive. So idea for binary is ones and zeros is like a light on, light off kind of thing. Right? Your circuits kind of open up and close it. So pretty soon you're going to see that the next generation of computing going to change this idea. So if you can have multiple states other than just ones and zeros, right? Let's say like you can have 10 different states. That's awesome, right? So that's exactly the next generation of computing that probably you're going to be learning. If you go to college, probably you're going to be learning in the future that change on binary, to having more of these different status, right? But here we are, right? We are still kind of working on binary. So that's what we need to kind of learn. But let's quickly learn about binary. I want to kind of show you that, I'm always kind of old school. I try to kind of go, explain a little bit, how it works in exactly how it is. But if you don't know like binary, I'll show you like how easy that idea of a binary means. So what it means by it is just a sequence of numbers. Anything that you can convert, our language, we can convert it to a binary. Right? What we have, the numbers, the characters, anything, exclamation mark, there's a unique binary code associated with that. Like let's look at this particular example. You can see that there's a number called 156. So this show you how to convert that 156 into binary. So it's very easy. It's just you divide by 2. Binary means 2 digits, ones or zeros. So idea is that you just divide by 2, divide, and then you kind of have a pattern that you write it this from bottom up. So you can see when I divide 156 by 2, it's 78. There's no remainder, right? When you divide it. So when you divide 78 by 2, you have 39, but there's a 1 remainder. Then you have 19, divide by that, you have a 1 remainder. 9 divided by 2, you have a 1 remainder. Because remember that you have a remaining part, the quotient and the remaining part, right? So that's always we write it that, what is remaining on the side. And then when you go to the end, you rewrite it on this way, from down to up, 1 1 0 0 1 1 1 0 0. So when you write it that way, that's the binary code. So let's see whether you got it. Let's see whether you can do this very simple one. So this, you have a 12, and let's see whether you can do binary 12. I'll help you with the very first one. So people who know how to do this, you can try and tell me what is the answer. Others, you can just work with me and tell me like how this works. So what is the way? I know it's very hard because I'm using my mouse to kind of do this, but I'm going to divide 12 by 2, right? So what you have is what? How to divide 12 by 2? What is the quotient and what is the remainder? So you have 6, remaining 0, right? Because if you multiply 6 by 2, you get 12. So that means no remaining. Now we divide again. Until you get 2, you need to divide 2 again. So you have 3, and then 0. Because why? There's no remaining for that. Right? Again, so I'm going to divide again by 2. You have 1 and 1 remaining. So you can see now, if I write it this way, you have 1, 1, 0, and 0. Right? So that's the binary of 12. So if you look at it, how to convert this one back to from binary to decimal, each position is actually something called 2 to the power, right? So this very first one is called 2 to the power 0, 2 to the power 0. The next one is 2 to the power 1, 2 to the power 2, 2 to the power 3. So if you add them together, you get 12 back. Because why? Like 2 to the power 0 to the power 0 of anything is always 0, right? So 2 to the power, that's always 1. But you multiply with whatever this thing that you have up there. So 2 to the power 0, right? You get 0, by multiplying. So 2 to the power 1, because you have 0, again that one 0. 2 to the power 2, right, is 4, because you have 1. 2 to the power 4 is 4. 2 to the power 3 is 8. So you have 1 right here. So you write that. So you have 8 and plus 4. Gonna come back to 12. So you can see that how it works. So any number starting from this corner, like, cornermost one, rightmost one is 2 to the power 0. Then you go one by one, 2 to the power 1, 2 to the power 2 position, 2 to the power 3, 4, 5, 6. So you can see now any number that you can actually go back and convert it to from binary to decimal, right? So this is the idea. I mentioned that, again, like if you're undecided about your career, I'll tell you the most exciting one is quantum computing. So if you are interested, I'll say, I'm really like, I really want to learn quantum computing. I mean, so maybe after next 5 years, when I kind of settle down, get like Banuka and my students kind of graduate, I'll probably gonna invest learning quantum computing. That's my goal. I mean, it's a lifetime learning, right? Lifelong learning. So I'm actually interested on learning quantum computing, and that's going to be the next generation. You probably know this, that IBM is working on quantum computing. Google is working on quantum computing. Microsoft is working on quantum computing. So your generation probably going to be working on quantum computing. What it means by it, you're not going to have binary, but you're going to have more status, that you can have a quantum status. You have multiple status. So it's very interesting that I want you to kind of, if you're undecided what you want to do in your future, I mean, that may be an exciting, if you're really good with math, if you have more like a quantity, I mean, your mind is more, you think always with the math, I'd say think about quantum computing as a career in the future, because you can make a lot of money. Any questions so far? I mean, I think I can see the chat window now. If you have any questions, you can ask, or you can ask from everybody also. Probably others can. If you see others asking questions that you can help, please, you don't have to, you can just go and answer, right? So don't sit and, just help others too at the same time. Sometimes I kind of like, I'm just carry on. Like, it's not like I'm teaching in front of a class, because I can see students struggle in a class. It's very hard to see that you are struggling in a virtual environment, right? It's something bad about the virtual environment. But if you ask it, or probably somebody else can answer if I don't see it. Make sense? All right. All right. Awesome. All right. So let's go a little bit further, and I mean, you can try 64 also, how to do this one at home, and let me know if you have trouble kind of getting that one. Right. All right. So right. So let's go a little bit further for the next one. So this is sort of a like binary of a lot of these characters and stuff out there. You can see that every character got its own unique binary code. That's how computer know this. Like if you press a key, computer know that, oh yeah, this is the character that you are sending. Right? So that's how computer know what we type, and how that computer know what is that, how to understand. That's unique. Every single thing got a unique binary code associated with it. And that's how computer know things, right? So that's how it is. So then what is programming? Then why we need programming? So the idea of a program is, computer is very fast. You're going to learn that, computer that I used to kind of work. My very first computer is called Pentium 3 866 megahertz. My RAM was, let me think, I kind of forgot like how much my RAM size was. I think my RAM size was 512 megabytes. This is back in 1998 or 1999, 1999, around that. So the very first thumb drive, those like pen drive, I got was 512 megabytes. I still have that one actually. I spent close to $50 for that or more, I think, maybe close to $100 for a 512 megabyte. And my hard disk size was 64 gigabytes at that time. So now you have terabytes of hard drives, right? And you have thumb drives that got terabytes on it. It's very different. The computer is very fast. But because it's very fast moron, don't understand anything, we have to tell, hey, just do this. Right? It's stupid. Computer is not intelligent. We are intelligent. We tell them to do something. So you are the one actually telling that to computer. Hey, we have this code, this program, do this exactly this way. So that's why it is, we are telling the computer, this is what you're supposed to do. So that's why computer program is required, that you want to tell the computer to do some complex stuff by writing things. And I said this, earlier, like computers are very unforgiving. They are dumb, right? You do something stupid, it can do some stupid stuff, right? So it will do exactly what you asked to do. You can see that, one simple code error can do disastrous stuff, like a nuclear plant can fail, or like a plane can crash, or rocket can fail because some small piece of code failed somewhere. Right? So that's why it is, it's very unforgiving. So you have to do a lot of trial and error, do some simulations again and again until everything is correct, right? Think of like sending a rocket, how much of coding that happened behind, right? So that's why it is important. So that's why we are learning programming. And what it means by this difference, I've said that machine language. So languages are closer to the computer, and there are languages are closer to the human. So back in the days, in the past, a lot of languages are closer to the machine. That's why it was hard to learn. A lot of, very close to machine level. Pascal and things like that, COBOL, like all these are very close to the language or computer language, and it was hard because of that reason. Now you can see like Python, even Java is sort of getting closer to the human. That makes it much easier for us, less and less complex. So that's what it means by a difference. So things are getting dumber down a little bit, so that we can kind of, make it easier. We can get lazy and write it in our language, so that, in intermediate, that happens something that convert to a machine language. Right? So exactly that's what happened. We write it in our own algorithms, closer to our language, and some program in the middle transfer it. So it's like a somebody who in the middle translator, right? Somebody who sit in the middle and try to think about the people do sign language, right? So you're giving a talk. There's a person, a sign language that do signing, right? That translate the stuff that we are saying into people who don't hear, right? Using a sign language. So it's exactly like that. The programming language, does that. They convert your stuff, what you're writing, into what computer can understand, machine learning. That's exactly so simple as it is. So you can see that what program does is that convert that from the point of what you write to a computer understand. So assembler was one of that very early assembly language, very close to machine, very hard to understand. And then, it's very hard to learn, but now it's getting better. Then there are tons of languages out there. This is just a kind of a representative one. But what do you think the most popular language at this point? Which language do you think the most popular? Anybody knows?
C++, maybe?
C++. So let's do a search. There's actually a space where that do a ranking. So it's called the what is it? TIOBE index. So TOB Programming Community Index. So this one actually ranks the programming language, coding language. So right now, C is kind of the number one at this point. So you can see that, but Java was actually there for quite some time. I'm even surprised now because I actually came here for after quite some time. So I actually was in mind, I was thinking of Java, right? But that actually changed, from last year to, you can see C actually came back for some reason. Python is actually gaining, Python, when I was looking at Python was actually at rank number 4 or 5, actually it came back to number 3 at this point. So you can see all the other languages, with the ranking. So this is a nice place to kind of go, like if you are like planning to do computer science. I mean, again, I'll recommend you don't try to learn every single language out there. It's not gonna worth it. You get kind of a, so make sure learn one language. Then syntax and semantics going to be similar. Like you can easily jump from one language to another. So my philosophy is, if I learn Java and C++, and then my philosophy is that give me 1 week, I'll learn any language, right? So that's what sort of a, like, your mindset should be, that because when you know the syntax and semantics of one language, easy to jump from one to another and learn another language, because it's learning what is the rules. Most of the rules are same, so it's not really going to change a whole lot. So that's why, like, you don't need to learn everything, but depends on what you are learning, gonna be different. Something like if you are really coding system programming, probably not to learn C, C++ or Java. If you're programming for web, probably you need to learn something called PHP or JSP or something. And then if you are programming for databases, you need to learn something called SQL. So you can see there are languages that specific to different things also. So when you go to college, probably you learn these different aspects, but you don't need to, like, learn everything. But what you need to know is that different things are there that, let me try to go back. Different languages are there specifically for different purposes, right? That's what I want to tell you. All right, so let's go quick to kind of give you a basic idea. So, so the basic idea is that you're going to see something called a source code. That's what you are writing, right? That's what you're writing, your code. And then every language got specific language or the grammar out of it. So we call it syntax, and semantics also part of it. And then you're going to see output. I'll show you an example. Output means that the program going to show you some result out there. And then you're going to have some sort of a console that you can actually see that output. So this is sort of the basic of a coding. When you do coding, you're going to see these aspects. Any coding language that you're going to be doing, you're going to have these aspects, out there. So what I mean by it, you're going to write the source code. Right? Remember, I mentioned that you are speaking English language, you are giving a lecture, and you have a translator that do hand signal, like the sign language thing, and they translate it to machine code. That's what happened. So these things gonna be different from language to language a little bit. Some languages gonna be different. Some language kind of create some intermediate files. And so it depends on what language gonna be using. When you learn those very specific language, you probably learn what is actually happening. But at this level, you don't need to necessarily learn it exactly what is happening. But at least understand that you are writing it in a source code, and program or the IDE, or I mentioned Google Colab, or I mentioned Anaconda Spider. They translate that to machine language and do something on that.